Okay, perfect. All right. Okay, so a precipitate is going to be a new solid formed in solution as a result of a chemical reaction. So a precipitate, okay, is the whole point of this chapter. No, I shouldn't say that. Is the whole point of learning solubility rules, all right? Remember, a precipitate was one of our signs of a chemical change. We really hit it when we were doing our different types of chemical reactions, right? And so just a reminder, it is not a liquid, not like precipitation, right? So this is a new solid that forms when you mix two liquids. So you saw it in a previous lab where you mixed, I believe it was like two clear liquids, and you and then it formed something that just looked like milk instantly formed or something like that, right? So you couldn't see through it anymore, and then you knew that at the end of the day, it settled to the bottom, which meant it was a suspension, right? So so that was our precipitate. So you've done this before, but you didn't really know how to find that yet. And so after today, you should now be like, oh, and it's going to be a piece of cake. You'll like it. So so again, that's one of our signs of a chemical reaction, precipitation reactions. They are often, this says single or double replacement. Just, we're going to really focus in on the double replacement because for single replacement, we tend to think of our activity series a little bit more. So we're focusing in on double replacement. So just a reminder, that was the one that we said was double date gone wrong. If that didn't help you back then don't write this down. Double date gone wrong. Right? That was our informal description of it, right? So we had two dates show up and then switch, right? So ultimately, when we are writing these out, you would take your two metals, switch their places, right? So now the metal is with a different anion, the other metal is with the other anion. And you have to re-crisscross charges, which was everyone's favorite part of the chapter. So we do have to remember some of that again. All right, a chemical reaction that involves formation of insoluble product. So we're really going to hit the insoluble thing today. That is your precipitate, okay? And that's how we know that a chemical reaction occurred. If your two products turn out to be aqueous, then you say that no reaction occurred because you had no sign of a chemical reaction. You just mixed liquids and you're like, yay, mix them. And that's it, all right? So you have to be looking for a precipitate to form. Something insoluble should happen. If everything is not insoluble, if they're all soluble, they're all in aqueous, then nothing happened, okay? The reactants are going to be soluble, but the product should be insoluble, or one of the products should be insoluble, and then you have the aqueous on the other one. Don't worry about this statement yet. We're going to get there next week, okay? So net ionic equation is just going to be a summary of a chemical equation. But this statement right here, I just want to hit that this is the reason we're doing what we're going to do today. And we have to use our solubility rules to know whether or not that reaction occurred because we have to know that something turns out to be insoluble. We have to know that we form this precipitate, right? Okay, so then there's this little example, but I want to point your attention to the states of matter. So you see that we have aqueous, those are my two reactants, and then you see that barium and hydrogen switch spots, right? And now we have one that is a solid and one that is aqueous. That's our precipitate, the one that turns out to be solid. And that's going to be the important reason why we're doing this, okay? You've got to know how to distinguish which one is a precipitate because that's the only way that a chemical reaction actually occurred. Make sense why we're doing it? Okay, even if it's a little foggy, that's okay. Just go ahead and turn your page back over. All right, so solubility rules, all right? And just on your paper, adjust this if you need to. If your S got cut off, please just put an S there so that you know that word is soluble. And this one down here should be insoluble, okay? So insoluble, and then this is just PPT. I think that would be the only other thing that got cut off. Everything else should be there. Okay? All right. So on this nice little chart that shows our solubility rules, just to point out a couple things. So you see that there's a list of these. Most of them are negative. Those are going to be anions. Okay, we have this list that says exceptions, and then you see that this part says insoluble, soluble, and then it just has an exception. Insoluble, exception, right? So I went ahead and hand wrote these pieces in, okay? And I did that to try to help you out. I want to show you that the soluble is going to be associated with aqueous. So when you go to write your states of matter, aqueous, right? And you see that it's also in this corner. And then the solid, that's the important stuff. If you get a solid, then that means that is the precipitate. If you don't get that, then it's not. All right, easy enough. All right, so the thing to remember with reading this chart today is that you want to think of it as 4 quadrants. So you don't have to draw this line, but I'm just going to do this just to make a point right now. You kind of have 4 quadrants in this chart, and you're trying to decide where you end up. And where you end up gives you your states of matter, tells you if it's soluble or not. Okay? The other thing that I did handwrite, and maybe I shouldn't have, but I did, I went ahead and told you, because you're going to see that there's an exception saying that if it has an alkali metal, and I'm sure we all remember our alkali metals, right? So group one, right? Column 1. So, and then I took it one step further. I'm sure I didn't mean to do that, but they're listed for you right there. Otherwise, you have a periodic table. You have your resource page. You have group 1 everywhere. So no excuses. You have them, okay? All right. I think that's all I have to say about what I wrote. So we're going to write down, the best way to do this is me to show you an example, and then you start trying it out on your own, okay? And when I say on your own, we're actually going to do 3 more examples after, but on a new page, all right? So for our first example, because that's the best way to learn this stuff, we're going to go ahead and have lead 2 iodide. Lead 2 iodide. All right, so first order of business, we got to write our formula, because if you look, those are all formulas, right? So lead 2 iodide. What is the chemical formula for lead? Pb. And then iodide. So the fact that it ends in IDE means that it's just an element. It's not a polyatomic ion. So what element is that one representing? Iodine. Good. So we're going to put I. All right. So it'd be great if we could just leave it that way, but we know that we can't. If you remember back 4 chapters ago, we have to crisscross charges. So lead, what's the charge on him? And here's the thing, do not look at the resource page. Don't you dare.
2.
It's 2, right? If you look at the resource page, what is it saying? Plus or minus 4, right? So don't look there. It's a transition metal, which means I have to give you the Roman numeral. Okay, so the Roman numeral tells us it is a +2. Okay, all right, iodine. That one you can look at the resource page if you want. He's in group 17, I think. -1. Good. So once we have our charges, we take them, we're going to crisscross them. So our formula is PBI with a little 2. That's going to be what we're going to base our notes off of. Okay? PBI little 2. All right, so now we have to figure out the solubility. So first step, look at the anion. Okay, so out of lead and iodine, which one of those 2 is the anion? So the place to look for this is here, right? Anions and cations. Okay, so cation, listen first, anions, listen second. Another thing to think of, positive charge, negative charge, metals, non-metals, you have 3 ways to think of it. So which one of those 2 is my anion? Iodine, thank you. All right, cool. So that's my anion, okay? All right, so we're looking at our anion. All right, so step 2, find anion in the chart. There's only 3 steps, by the way. Okay, find your anion in your chart. So we're going to find iodine in that list. So looking down the list, there it is. All right, so I found iodine. It's up here in this top quadrant. right? Okay, so I found it. We're good. Step 3. Oh, okay. Step 3 is read your rule out loud. Oops. Your rule out loud. All right, so what I mean by that, you're going to say something is something unless something. Okay, that's the skeleton of it, all right? So what we will say, iodine is, what quadrant is it in? Soluble. Unless, that's a key word, you gotta say that word, unless with, this one has silver, lead, mercury. Oh, I'm totally off the page. I'm so sorry. Here you go. Unless it's with silver, lead, or mercury. Is it with silver, lead, or mercury? Yes, it is with lead. So that means we now end in this quadrant. So what is it? Insoluble. And that's your final decision. That's the answer. All right. So this one is going to be insoluble, or solid, or precipitate. Okay? But you saw how we kind of did that. The whole point of that sentence here, let me zoom in because I know some people, you guys are still writing it down. There you guys go. So the whole point of that sentence, the reason why it's important is because you have to say it out loud. That way you know the unless part, the exception part, to see where you're landing every single time, okay? All right, so I am going to do this real quick. I know they're going to release you about 10 minutes, so I'm going to zoom through 3. I'm going to do 3 of them with you, and that way you should walk out of here with at least 3 done.
Ice cream. You have a bowl stick? Yeah, so. Yeah. You're. I'm not going.
Okay. Let's take a look at the page. Let's dive right in. So we've got, for the first one, it kind of looks really scary. Okay. So this is going to be, if we were to look at our polyatomic list, that is NH4, ammonium. And then this part is actually acetate. And I realize on your polyatomic list, we don't have it written that way, but it is like that on your solubility rules part, okay? Now, what I don't want to have happen is you get stressed out and bogged down today with writing names and formulas, because that's not the point of today. Today, the point is solubility. So do your best. You can usually get away with writing you can't really mess up the formulas, okay? It won't ruin the solubility rule if you accidentally forget your subscript or something, okay? So just don't get too bogged down with that. All right, so let's run through our steps. So we're going to look at our anion, that's acetate, right? So we're going to find acetate on the list. So acetate, 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 up here. All right, so acetate is soluble unless, is there any exception to that rule? No. So what's the answer? Soluble. So we're going to go ahead and say aqueous, soluble. I don't recommend doing S and I, because then you're going to get confused and you're going to start thinking solids are soluble, and don't do that, okay? So aqueous, soluble. All right, number 2. Ba, that is barium. Who is OH? Hydroxide. Good. So we're going to really be seeing that one a lot in acids and bases in the next chapter. It's one of our strong bases. All right, so we're going to find hydroxide. So find hydroxide on our list. I'm looking. Oh, it's down here. All right, so hydroxide is insoluble unless it's with NH4 or an alkali metal or calcium, strontium, barium. Is it with any of those? It's with barium. So we're in this quadrant. That's where we're ending. So now what's the answer? We're soluble. We're aqueous. Okay? All right, our last one, iron 2 carbonate. So iron 2. What's iron? Fe. And what does the 2 mean? It's a +2 charge, right? Carbonate. What is carbonate? CO3. And just so you know, they're not just guessing on those, okay? They're right here on your polyatomic list, okay? So CO3 up here has a -2 charge. Okay, so those are going to cancel each other out, so we don't have any other subscripts. Moving on, we find carbonate in our list. So we're going to look at carbonate up here. So we are insoluble unless we're with NH4, that's not NH4, or an alkali metal. Is iron one of our alkali metals? No. So we are staying in this quadrant. That's where we're landing. Okay, so that means that we are solid insoluble. That right there, that's a precipitate if it was one of our products. Okay? Any questions so far? Okay, you guys try some on your own. Again, I don't want you to get confused with the formulas and naming. So along the way, if you want to check up here with the formulas and naming, just to make sure, because you're just nervous that you're writing the wrong formula or something, please check up here. I'm not going to put all these answers all the way down, not for today. But your goal is to try to get through the solubility rules. Okay?